Hello Spark fans and welcome back to Advancing Spark, where today we're having a look at DLT or Delta Live Tables' new ability to merge data. Now that seems like such a no-brainer, obvious, I just want to be able to do an upsert, right? But it's been a missing bit of functionality in DLT since it came out. So it's very exciting the fact that we can now do it because it opens up all of the same patterns that we're currently using in any mature lake, in any mature warehousing system. You're going to be doing some kind of upsert. You don't want to be just appending data to the bottom of a table or completely overwriting an existing table, and that's all we've been able to do so far. So super exciting that this is there. Really crucial step on the path to having DLT as a real potential tool to build out your entire lakehouse using. So super exciting stuff. We're going to take a look through the syntax, have a look at the Delta table underneath, a few gotchas, bits and pieces about how it actually works, and yeah, we'll have a bit of a tour. As always, if you are new around here, don't forget to like and subscribe. Let me know down in the comments what you're thinking of DLT. Is it getting closer with each of these incremental updates and the new features and the bit of polish on the top to being what you're looking for as your lakehouse platform of choice? Or are you still going, nah, I'd prefer to write the code myself? And it's going to be interesting to see how many people are on each side of the fence. Right, first, let's have a bit of a look at why this is so crucial. Why is this so important? Got my notebook out again. Rarely actually draw things for you these days. All right, so we've got some kind of source system. We've got some data from somewhere, and we're following. So in this example, we'll go through the Databricks medallion architecture. So we're going to say this is going to be our bronze area, and that's going to flow into some kind of silver area, and then that's going to go into some kind of gold. So that's normal three-step process. So as DLT currently works, if there's new records added over here, we stream them over and we can just append them as a stream. So we're not bringing over the entire table. We're only bringing back the changes that have happened since we last ran, and we can stream those into our bronze layer. Now, silver's where we'd be doing some cleansing, some tidying up, some kind of fixing of the data. But currently we still have to have that as an incremental stream. And at that point, we're normally leaving bronze and silver as kind of one-to-one. We're not joining it to many other things. We can keep it as an incremental push of data. And then when we get to gold, that tends to be well, I'm just going to rewrite that table because I'm going to re-aggregate everything. I can't figure out how to apply changes. Having a stream that joins across a load of different tables is really painful. So let's just wipe out the data and overwrite it with a new version of that data set. We have kind of an append, and a complete overwrite. That's currently what we can do in DLT. So with the new changes, what this means is we've got some new fancy data coming over in rainbow mode. We'll still do the same append into raw. But now, rather than having the same append happen into silver and we have to pick through all those changes, actually we can get rid of the idea of appends and we can merge it. So that silver becomes the kind of the real kind of the source of truth for actually the latest version of that data with changes and lineage and validation expectations applied. We can treat that as our good, valid copy of the data. And then honestly, we'll probably still end up doing the let's get rid of gold and rewrite it if we're doing lots of aggregations, if we simply have to update all the data because the underlying data's changed. Now, at some point, I would like to be able to do that as a partition basis and go, actually just overwrite that bit, this year's data, this rolling month's data, this day's data. But currently it's kind of, you can't do that in DLT from what I've seen. So it is kind of a append, merge, or completely overwrite. But at least this crucial step, this ability to merge into the center of our data curation workflow is fairly huge. Okay, so let's have a look at how that actually works. So there is the documentation is now out and live, and you can go in and have a look at how it works. So they've called it change data capture with DLT, which is a little bit weird because it's not quite the same as Delta change data capture. So you're not seeing your Delta folders with the CDC elements in there in a separate copy of your updated records. You're not seeing that. Ignore that. But you are applying a merge statement. And that's essentially what DLT is. Delta Live Tables is essentially an abstraction on top of Spark that lets you write simplified code that turns it into the same code we're using when we're building out engineering stuff and we're doing things manually. So essentially, it's write some simple things and it'll write a big, hairy merge statement for you. That's all it's really doing. So what have we got? Firstly, we need to turn it on. So there's a configuration that we can apply inside our pipeline settings to say, yes, please actually have the apply change functionality. And we'll get onto that as a term in a second, because that's what we call the merge statement now. So specifically, if we're in DLT and we want to do an upsert and a delete, we want to do a merge, it's not called a merge statement, very crucially. And there's a real decision about that, right? Because they didn't want it to be confusing when you're writing a Spark SQL merge statement that's deliberately built to be very, very similar to ISO standard or ANSI standard merge statement. It looks and feels like any other SQL merge statement and has the same syntax and same operators. Because this is an abstraction on top of that, that's actually writing a merge statement for you, they didn't want you to write merge and then have to remember that you're doing the DLT version of merge and so go one way and then that's the other flavor. So they called it something completely different. So you apply changes from here into here by joining on this key with these conditions. This is what to do when it matches and doesn't matches. All the same familiar stuff that you see inside a merge statement, very deliberately called something different to avoid confusion or cause confusion or avoid confusion. And we'll see how it actually goes down. So in this case, this is the SQL flavor of it. So I want to apply changes into my target table from my source table. Again, both Delta Live tables. One of them going to be a normal timing. We can kind of mix and match, I think, in terms of the source that can be coming from a normal table. But we're assuming we're going into a DLT. And then keys. How should it work out if the record already exists or not? Which is the key to join in. Essentially, it's our merge constraint. And they've separated out two things. So you've got the where condition to say, so this is the key to join on to see if it exists, but only when it satisfies this condition should you actually apply the update. Whereas previously, I mean, in a normal merge statement, you can jam that into one big, essentially, join condition. So there's now a separate thing saying, this is the name of the column that has to appear on both sides. So if we say this is my primary key, then my source incoming data has to have a column called primary key. My target table has to have a column called primary key, and it's going to automatically just write a join, assuming both sides have that same column. So keys has been simplified to make it easy, but also put some conditions on you in that both sides have to have the same column. Ignore all updates. Don't bother updating if nothing's changed. We can apply deletes. We've got sequence by. Now, sequence by is really interesting, and there's two different things in there. So, firstly, it allows you to rerun the merge, which is a massive thing. So, if you got 3 changes at once, and the same record, the same primary key, the same record ID 3 times in the set. Normally, if you try and merge that into a merge statement, it goes, no, it's not going to work. In this case, it's actually sort of handling that by taking that some kind of ordering, some kind of modified date, update date, system time date, and allowing you to actually sort of pile them up and actually sort of work out which is the most recent record, therefore which should get applied. So it has that in there. It also allows you to take a look at, should we bother updating this? Is it going to have changed? Well, what's the sequence? No, that date's the same. We'll treat this record as not having changed. So there's interesting bits and pieces by the nature of how they've written this as to what it means if you give it a different record but has the same ID and the same sequence number, not going to update it. So a couple of gotchas to get used to, but actually some really useful functionality in there. And then we can say, here's a list of columns that should be updated. So you don't have to update every single column in your table. You can say, bring these changes in, apply all the actual data column changes, but don't change my audit date of when I originally loaded this thing. I want that to stay in there, so I've got a record. You can do things like that. It allows for slowly changing patterns if you want to lock down certain keys. And you've also got on the other side the except. Update everything except that column because I want to keep that column. That's mine. So yeah, really, really useful. And again, fairly simple if you're used to merge statements. It's just accepting the fact that there's some slightly different syntax to make it different. Okay, then on the Python side, again, following that same thing, it's not a merge. So we're no longer doing the go get a Delta Live table, do a DLT.merge, or do a Delta, sorry, not a Delta Live table, go and get a Delta table, and then Delta table.merge is what we'd normally do if we're writing a normal Delta merge. And now we're doing apply changes. So we're just running an apply change function. And then that has certain things it's asking for. The target, makes sense. The source, the keys it should join on, the sequence by, all the same stuff we saw in SQL, just in Python mode. Now there's one little gotcha that normally gets people when they're writing merge statements is if you're trying to write something really super generic and you can onboard a new table and throw it through that same script and it'll get some data and it'll merge it in and it's all good. Unless the table doesn't exist. In which case you have to end up having little if statements going, just check see if it exists. If it doesn't exist, create a blank empty delta table that I can then merge into. And it's something we've built 100 times, right? And you have to kind of do a similar thing here. But the syntax is just a little bit confusing when you first get to it. So the Python sample that they've got, so saying import DLT, import some SQL functions, that's fine. Grab an existing Delta Live table, well, define a Delta Live table view by streaming over this existing table. Fine, happy. Then we've got this DLT.create target table function. Now I had to dig around and I can't actually find a definition for that anywhere. So just taking it on faith that that makes sense and does a thing, but we can go and have a look at what that actually does under the hood. So yeah, it's essentially, we're saying this table, the target, the table named target is defined by create it if it doesn't exist, essentially. And then we're doing a merge, a DLT, apply changes, merge my data, go into that target table, which again, create it if it doesn't exist, take my source table, which again is this, we defined it as SRC in this view up there. Assume that both sides have this user ID, sequenced by my sequence number. Do this. If it says it's delete, then you delete it. Don't update my operation by sequence number. So it's got essentially similar commands. So I took that and I thought I'd have a go. So I saw something that was I'd originally written as my kind of framework automated version. It was all very, very generic. And then I just ripped out all the genericism and turned genericism, is that a word? And then made it fairly hard coded. So what we're doing, there's a load of autoloader stuff at the top, so we can go and see getting secrets, applying cloud file settings, because I'm going to stream in from a blob store. There's all of that, blah, 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 blah. And then we're saying, okay, I'm making a view. So I'm making my bronze view. And again, same as they were doing in the example, spark.read stream. I'm using cloud files, so I'm using autoloader here, passing in my options, go to there. Nothing crazy, same as we've seen in previous videos. Then I'm taking it in faith that I'm going to DLT.create my target table of my silver table. Now I did try and run that in isolation. I ran that just with a completely different table name. I just went down here and went, okay, what if I did something else down here? Whatever. I ran that, and that comes back with an error saying, well, that table's not defined anywhere. That's not a thing. We don't know what that is. So there is an intrinsic link in that whatever we call this thing inside that create target table also has to be included in the merge, so it knows what the syntax is, what the schema is to apply to that blank table. It's something of a paradox. So we've got our apply changes. I'm saying go into that table, and we put a reference going, if you can't find it, create it. From that source, which again is the view that we've got up there. Both sides have to have sales order detail ID. And there's a modified date in there that we can use to work out if things have changed. That's what we have. So I came over here, I created a new Delta Live table pipeline, and I set it up. So I've got my apply changes preview enabled. Weirdly, it also worked without that turned on. So maybe it's actually rolled out now and you don't need it. But still, I put it in just in case. I've got my cluster settings. I mean, I'm only using one worker, I'm being nice and cheap here. And it's pointing to that notebook that we just looked at. That's it. That's all the settings I need. I can say, go and start. So I've cleaned down the database. I've cleaned down the folder. So if we go and look in here, we don't currently see that DLT merge folder. So we're expecting this to go and do it. This is actually another interesting thing. This creating update, waiting for resources, initializing, that's new. So previously, we just had the graph's not ready yet, and we wouldn't see anything. It'd be like, okay, great. But actually now, even while it's waiting to spin up the cluster, we'll have a little progress bar saying, I'm waiting because I'm spinning up the cluster. So there's some nice UI changes that have kind of come in to tidy some of this stuff up. You might also note that we're now going horizontally, not vertically. So original Delta Live tables were starting at the top, and then things were flowing downwards. And just from convention, a lot of ELT tools, a lot of kind of data transformation tools these days go, I'm starting over there, I'm going to slowly move across and put things across the other way for you guys. And you see this data going through. So we've now got a slightly switch of the UI for things. Okay, so that's still running, but we'll start being able to see some of this stuff. I've got my bronze view. I can go and see the view that was going through. And I've got my silver view. My silver table that I'm merging into. And there's a couple of things we can see there. So from my bronze table, it went up to there. That was the schema of my bronze view. You can see I've got the same details when I'm in my silver side, except it's automatically added 3 system columns on of my timestamp, my delete version, and my upsert version. And those delete versions and upsert versions based on that sequence, aka the modified data I've passed through in this case. So actually when we do the merge, actually building out a more complex predicate under the hood that says, if you get some new data in, but the version hasn't changed from the version that we say, don't bother updating it. And that's kind of like a little thing it's building for you to stop you having to write out that massive script yourself. Okay, so that's red. So we can see that's gone. I don't think we've got any details in here. We can see the flow's completed. Great, you've got some data. So let's go and check what's happened under the hood. We've got dlt.merge. We can go and look at that folder. Got my things in here. Got my various checkpoints in my tables. I have a folder for bronze. The views don't normally create a table folder. It's only because I put the schema in there because I'm using autoloader's schema inference. So I've kind of dummied up that same thing. Main thing is silver. So I've got my delta live table. I've got my delta table created here inside that location I told DLT to put everything inside. And we've got some Parquet. That's what I'd expect. I've got some data. I've merged it into the table. We're going to see things. So inside the transaction log, we've got 2 things. We've got 2 transactions have happened. So this is the first time I've ran it. That folder didn't exist. I've hit go and it's created 2 transactions. Now that's because of that create empty table kind of script. So we'll see the first thing that's actually done is there's no data here. It's done something to say, okay, I'm creating a table. It's going to be Parquet under the hood. Here's the schema of the thing that it should be. This is the DLT pipeline that's actually doing it. So this is actually pipeline information that's gone into it. So it's spun up this delta table and intrinsically configured it to be a delta live table delta table. We can even see this is not just a create table script. There's a new delta operation that's been applied, which is DLT setup. So it's initializing the table, but it's doing a special initialization of that same table. But then just an empty thing. So it's got the schema. So it's got the schema from somewhere. It's obviously taken that schema from the merge statement and used it inside here. Interesting. Okay, so we can take that. So we can see what's inside there. And then we can have a look at the other transaction. And this is going to be much more what we expect. This is the actual merge happening. So we can see it's added a new Parquet file. We can see the number of records, 641, modified date. We can see all that stuff going in. We can see it just did a straightforward merge. So it's the same as if we wrote our own notebook and we said, merge our data into this table. It's doing a merge action. But we can see the predicate that's built for us is not just we've got that straightforward detail ID equals detail ID. So that's the match predicate. Does this record already exist? But then when deciding whether or not it updates matched predicates, it's actually built out a whole update string, which is all to do with those system tables. So if the update version is greater, so if our source update version is greater than our target update version, then update it. So if you gave it some changes where that modified date hasn't changed, it's not going to make any changes. So actually it's adding more complexity. It's basically putting some belt and braces around the basic merge statement that we've defined to make it a little bit more robust because we've given it that sequence by parameter. And we get the normal metrics as well. We can see we've added a file, we've added 641. We didn't update any rows because the no rows existed. So very forward. Let's do a bit of a test. So I'm going to go back. This is the location that I'm actually sourcing this data from. I'm going to go and upload some new files. You can see I've had a plan and done this before. I'm going to put some unchanged data in. Okay, so I'm going to upload that. So this data, the modified date, my sequence by, hasn't changed. So even though it's got new copies of the data, it's seeing a new file come in. It's got some extra stuff. It's got a load of new records that have IDs that already exist in my source table. But actually what we're expecting is because the modified data is the same, hence the underscore update version or upsert version is the same as the upsert version that already exists, we shouldn't see any changes applied. So ideally, we shouldn't even see a new Parquet file. So it shouldn't have to copy data over. There should be no redundant copies of rows. Nothing has changed in this update. Even though in our bronze table, we're seeing this new file and this new set of data, we're doing a nice efficient merge because we have the sequence by number that it can actually look at. So we'll give that a second. That'll go and apply it. And then we'll have a look at that transaction. And then we'll put some change data in it, and we'll make sure it only changes the stuff that's changed. Makes sense. Now, whether or not you want to use just like there is a source system date you can use for that, or if you're doing some kind of checksum, you're building out some kind of timestamp that has a little bit of validation baked into it. There's a few different ways you can actually build out that sequence by field that you pass into it to be used by this, depending on whether or not your source data has a modified date, a system date, some kind of timestamp you can be using. I don't know whether we could use things like row version coming from a SQL server, or whether that would make any sense whatsoever. I don't know. So things that we can look into it, but it's interesting that that is baked in because it is just so simple. The actual merge statement I'm doing, saying take those changes, apply them, use this date to figure out if it's changed. Nice and straightforward. So that should only take a second. We'll be able to take a look. There we go. So that's run. So we should see my new one's completed. I can go and have a look over here, see what's happened in terms of that transaction log. So we've got a new transaction. So it's done something. And then if we just take a sneaky look up, oh, hasn't changed anything. So we had one Parquet file before. We've now still got one Parquet file. So it did a merge transaction. It said, yeah, I've done something. You asked me to do a merge. This is everything I was doing the merge on. So the same set of predicates. But number of target rows copied 0, number of rows deleted 0, number of rows inserted 0, because nothing had changed. Because nothing triggered that difference between the upsert version and the target upsert version. Adding these extra criteria in to stop us from doing redundant updates. That's the final thing. Let's go and make sure we can change it. So I'm going to come in here, I'm going to upload some data. I'm going to upload some data, some of which has changed. Some has got entirely new IDs. All of them have a changed modified date. So actually all of them should trigger an update regardless of whether the actual date has changed. We should see them treated as a change because we're determining change based on that modified date. Kicking it off again, we'll see that flow through. Set up the tables and push it through. We'll have a look at our transaction log. We'll see a new transaction, and I'm hoping we'll see just one new Parquet file, and it will have taken all the existing rows over because it was updating some, brought them over into a new file along with the new inserted ones, and then it's tried to done it as a normal merge, the same as if we wrote that merge ourselves. That's what we're looking for. And yeah, definitely seems to fit in, seems to make sense. This is all stuff that I would be doing if I'm writing this stuff manually. So this does make a lot of sense. We'll give that a second or two. We'll see that going through. Again, it's nice that I can have this in development mode and just keep restarting it without having to wait for a cluster to turn on. And then we'll see what happens when we actually apply these changes. Now, I'll be interested to see people who actually tend to go for the Python-y version and build it slightly more frameworked and build it inside, getting some metadata, putting it in, deciding what the sequence number is on a table-by-table basis and passing that in as a parameter. Or if people are actually using this going, you know what, no, I was looking for something where I can just write SQL. And yeah, I'll have different notebooks for each of my different tables, but that's fine because I like writing SQL. And it'll be interesting to see the mix of people using this as something they can just write a real simple framework over the top versus people actually using it to allow business users to write SQL for themselves. I don't know. Personally, obviously, I like writing code. Okay, so then we can take a look at this new transaction. We'll see what's happening in here. And again, I'm expecting this to have a new file in there. Okay, there we go. So it's removing the old file and it's adding two new files. Okay, so it's separated out inserted rows from changed rows. Makes sense, that's fine. So we've got one file going in, which has had the updates applied to it. And we've got one file going in, which has had the new inserted records that didn't exist. And then we can see the changes in here. So what have we got? So we've got two new files added. We've got 3 rows inserted. And then we've got 631 rows that hadn't changed, that got copied across, and 10 had changed. So our original file had 641 rows in there. 10 of them have updated. 631 of them haven't changed. And it's just copied them all over into a new version of that file. And then there's a separate file, which is a little bit inefficient, which only got a handful of records in there. Oh, actually, no, that's not what it's done. Oh, okay, so it's taken all unchanged records and just put those over into a new file, and then all of the changes together into a separate new file. So that might be doing something merge stuff behind the scenes, just to make it a little bit easier rather than having to separate that stuff. Interesting. Okay, but we can get all of that details. We have the transaction log. We can go and inspect it and poke it and say, what are you actually doing under the hood? And yeah, that's kind of all I wanted to take you guys through. So, new stuff. We have this thing called CDC in Delta Live Tables. Don't be confused. It is all about doing merges. It's all about being able to apply changes and upsert and delete data in an existing Delta Live table by using a simplified version of the merge statement called apply changes. You can do it in SQL, you can do it in Python. And yeah, seems kind of interesting how it's actually working behind the scenes. As always with Delta Live Tables, don't feel afraid. You can go and look at the actual Delta tables if you want to get under the hood. It is nice and exposed, so it's not a black box. You're not allowed to see it. It's just it's going to make it easy. It's going to simplify things for you. And then you can go and have a look at what it did under the hood. That is all I wanted to go through today. So again, really interested to see how people actually find it. Really interested to see kind of people's thoughts on that implementation, calling it apply changes, moving away from merge as a statement purely to avoid confusion. And yeah, is this something people are excited about? Is this something that makes people go, yes, right, I'm going to use DLT as soon as it's available? I'd love to hear what you guys think about it. As always, don't forget to like and subscribe, and I'll catch you next time digging into more technical nerdery. Cheers.